Hey everyone, welcome back to another Prep Math for Fun video. And in this video, we're going to do a question from the AMC 10A 2020. And I chose this problem because it's a good combination of probability and combinatorics as well as number theory, because you're using divisors as well as finding the probability of an event. So the question reads, a positive integer divisor of 12 factorial is chosen at random. The probability that the divisor chosen is a perfect square can be written as m divided by n. And we're asked to find m plus n. And obviously m divided by n is going to be in lowest form. So we're going to have to simplify the fraction once we get a fraction. So this looks like a lot of words, and I would like to simplify this. So the question is basically stating that we want to find the number of perfect square divisors of 12 factorial and divide it by the total number of divisors, and then add the numerator and denominator of that fraction. So whenever we have the term divisors, what we want to do is always factorize the number in question. So we're going to write the prime factorization of 12 factorial. So 12 factorial can be rewritten as 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 all the way to times 1. And now we just have to prime factorize each of these numbers individually. So the prime factorization of 12 is 2 squared times 3, 11 is just 11, 10 is 2 times 5, 9 is 3 squared, 8 is 2 cubed, and so on. So this is just going to be 2 squared, then 3, and 2. And when we combine all these prime factors up, 12 factorial is going to be the same thing as 2 to the power of 10 times 3 to the power of 5 times 5 to the power of 2 times 7 times 11. And if you guys want a quicker way of finding the prime factorization of 12 factorial, I encourage you to look up Legendre's formula, because it's really fast way of finding the prime factorization of really big numbers. But we won't go into that. We won't go into detail for this video. So now that we have the prime factorization over here, we want to find the total number of divisors. And if you guys don't know, the formula for the total number of divisors given the prime factorization is you multiply all the exponents, but you add 1 to each of the exponents. So it's going to be 10 plus 1 times 5 plus 1 times 2 plus 1 times, this is just to the power of 1, times 1 plus 1 times 1 plus 1. So you see here that this is to the 2 to the power of 10, so that's 10 plus 1. This is to the power of 5, so that's 5 plus 1, and so on. So, well, what's that equal to? Well, when we multiply this out, this is all going to be equal to 792. So it seems like the total number of divisors is going to be 792. And that seems like a likely candidate for what n is going to be. So now let's try finding the total squares, the total number of perfect squares. So we're going to keep a note over here that the total number of divisors is 792, and then we're also going to keep a note of what the prime factorization was. And it's going to be 2 to the power of 10 times 3 to the power of 5 times 5 to the power of 2 times 7 times 11. So we're just going to keep that as a note because it's going to be really helpful. And now we want to find the total number of perfect squares. Well, what is a perfect square? A perfect square is when the exponent is a multiple of 2. So, for example, 2 squared is a perfect square. 2 to the power of 4 is a perfect square. 2 to the power of 6, and so on, all the way to 2 to the power of 10. And we can combine these perfect squares. So it's not just powers of 2s and powers of 3. It can be something like 2 to the power of 4 times 3 to the power of 2 times 5 to the power of 2. That can be a perfect square. So we need to find the total number of these that exist. So let's start by listing them out and see what happens. So we're going to start with, what if it's 2 to the power of 0? So it's just going to be 1 over here. So a possibility for that is another 3 to the power of 0 times 5 to the power of 0. So that's just 1. Okay, that seems like a divisor of 12 factorial. What about 2 to the power of 0 times 3 to the power of 0 times 5 to the power of 2? That's 25, which is a divisor of 12 factorial. Now, 2 to the power of 0 times 3 to the power of 2 times 5 to the power of 0, that's 9 right there, because it's 3 squared. But this seems really tedious because we're going to have to go through every single possibility, and we don't really have that much time, especially on an AMC test. So let's try to find a quicker and smarter way to do that. Well, we're gonna use some counting principles over here. So we realize that for choosing a power of 2, we have 6 options. We have 2 to the power of 0, 2 to the power of 2, 2 to the power of 4, 2 to the power of 6, 2 to the power of 8, and 2 to the power of 10. We have these 6 options over here. And for choosing a power of 3 to the power of 5, we have the options of 3 to the power of 0, 3 to the power of 2, and 3 to the power of 4. And for choosing something from 5 squared, our options are 5 to the 0th and 5 squared. And for choosing something from 7, well, there isn't really any specific choice for 7 except from 7 to the power of 0, because there's no squared here, or there's no even power over here. And same applies to 11. So I'm just gonna put 11 to the power of 0 over here. So it seems like we have 6 choices here, 3 choices here, and 2 choices here, and 1 choice for both of these. So, do you know how we could rewrite choosing from that many choices? Well, easy. It's just going to be 6 times the number of choices here, which is 3, times the number of choices here, 2 times the number of choices here, which is just 1 times 1. And 6 times 3 times 2 simplifies to 36. So, this means that our fraction is going to be 36 divided by 792. And all that's left is just to simplify that. So let's just go about simplifying that. So 36 divided by 792. Well, it seems like 8 is a divisor of, it seems like 9 is a divisor of both of these. So this can be rewritten as 4 divided by, 8. 8 goes into here. And then that leaves us with another 8. So it's 4 divided by 88, which can be rewritten as 1 divided by 22. And we're asked to find m plus n, so 1 plus 22 is simply just 23. And that is our answer for this question over here.